This function here is in the form a sine of n theta, and these are what we call rose curves because they kind of look like flowers with petals. N determines the number of petals that we have. If n is even, or I'll start with odd, if n is odd, then we have n petals. If n is even, we actually double that number and we end up with 2n petals. Okay, well, here, of course, n is 4, and so we're going to have double that. We're going to have 8 petals. Whoops, we have 8 petals. A is that number in front. That tells you how long the petals are. That's the length of the petals. And so these, of course, have a length of 3. All right, now we need to find out the positioning of our petals. And so we do that by setting sine equal to 1, this sine of 4 theta, because that's going to be, when it's the biggest, so that's going to be the location of a petal. So we're going to set this equal to 1. The first time that happens is when we're taking the sine of pi over 2. So we need 4 theta to be pi over 2. So that means theta is going to be pi over 8. Okay. Now the location of all the different petals are just going to be, we just add whatever we need to get to the next petal. We have 8 petals. So we take the full revolution around and divide it, that's 2 pi, and divide it by 8. So it's pi over 4. So we're going to be adding 2 pi over 8 to this. So we have 3 pi over 8, 5 pi over 8, 7 pi over 8, 9 pi over 8, 11 pi over 8, 13 pi over 8, and 15 pi over 8. And those are the 8 locations of the 8 petals. So now if we go to, if we draw our axes, and I'm not the best artist, but I'll try here. So we go to pi over 8. Pi over 4, of course, is there, so pi over 8 is just going to be half that. Oops. So we have that, and let's actually do this in a different color. Okay, so that's going to be the location of one of them. And then we go to 3 pi over 8, so that's going to be right there. And then 5 pi over 8, that's going to be right there. And 7 pi over 8. 9 pi over 8. Oops. 11 pi over 8. 13 pi over 8, and then, of course, 15 pi over 8. So these are the kind of going to be the locations of these petals, and this is the part that I'm really bad at, and that's drawing the petals. They have a length of 3, so they come out, 1, 2, 3. So boom, boom, boom. So they all come out to 3, and so we just kind of draw those petals coming out. And I'll show you this on a graphing calculator after we do this, just so you can see what it's really supposed to look like. So these petals all come out. They all have a length of 3, and these, of course, are angles we found. These locations. All right, so that's kind of a basic idea. Let's go ahead and let me show you on the calculator how this works. First, let's put it in polar mode. And we have r equals 3 sine of 4 theta. And then we'll graph that. And you can see doing all those petals. Let's go ahead and zoom in. And you can see that. So it traces them out in that order. But there you get your petals.